dear students, welcome to the e-learning class. Okay, so it's your physics class, and today we are going to learn about the electricity. Okay, in our last class the class didn't run well, so we will repeat that class, electricity, again. Okay, so let's start the class. So as you know that you also live in a home, there are so many electrical appliances. Okay, either it is fan, or it is TV, or it is radio, or anything. All equipments are connected with the electricity. Okay, so they all run on the electricity. So here you can see that bulbs are glowing, fans are running, and there is another TV. All appliances are working, and they take the help of electricity. Also you can see that in your kitchen your mother is preparing food with mixer grinder, fan is rotating. Okay, so all these appliances works with the help of electricity. So you already know that that there is a electrical circuit. Okay, here you can see this is called switch, then there is a bulb, then there is it is called energy source, and here it is a battery. Okay, so it is connected to a battery, then it is connected again a switch. So what does a switch work? Yes, it can on and off the circuit. Okay, it can open or close the electrical circuit. So here you can see that if we if we close the circuit, then the bulb is glowing. So here the electricity is converted into light. And after switch off, then there is a heat. Okay, so here we can see that the electrical energy, it is converting into light and heat also. If you can see a electrical bulb, so it produces light as well as heat also. So here we can see that a bulb is produce light and heat. So battery or cell is a source of electrical energy. Now we know that electricity can be converted into light, but what about heat? How can electricity produce heat? Okay, so recall the term resistance. What is the resistance? Can you tell me? Yes, very good, students. Resistance is the hindrance in the movement of electricity. Okay, so here you can see that these electrons are moving. Basically these represents the electricity or current. Okay, so these are moving inside a wire, and this wire, it is made up again, the wire is again made up of molecules, atoms, and many particles. Okay, so what does the particle, if they can flow, then they always collide with these atoms of any metal or any wire. And you already know that if two bodies collide, then they always produce heat. So this is the reason of producing heat with the electricity. So here electrons collide with atoms. During collision there is a liberation of heat energy. Okay, I think now you have understood that why electrical appliances produce heat. Either it is electrical bulb, mixer grinder, or it is a fan or TV or anything, they all produce heat. So materials which have more resistance are more heated. Okay, so if it has more resistance means it is fully packed with the atoms, so it has more resistance and it produces more heat. So here you can see all these appliances produce heat. We can observe with electrical light, with fan, and also with mixer grinder. Okay, so lighting, this is useful work because we why do we use a electrical bulb? So what is your answer? Yes, obviously we use electrical bulb to get light. Okay, because if it is dark then we use the electrical bulb. So this is a useful work. Again, for fan, it is rotating. When it rotates then it produce wind. So this is it rotating, and again mixing, this is again useful work. But what is wasteful here? Because some electricity produce waste. A part of electric current is converted into useful work. So we have seen that these are useful work, and rest of the source energy is liberated as heat and appliances get heated. So this is called waste of energy. So this is called unnecessary heat. So here today we will learn about the heating effect of the electric current. So there are also application of heating effect of electric current. So let's see what are the uses. First, what does she doing? What is she doing? Yes, she is ironing the clothes. Okay, and she is using an electrical press. So with the help of electricity it produces heat and then she can iron the clothes. Again, water heater, it is used to heat the water. It is room heater, coffee maker. So all these appliances use heat to give us useful work. Again, electrical light. So here all these appliances have some rotating components. Okay class, now it's question time. So give the answer. Which of the following is not a consequence of the heating effect of electric current? And your time starts now. Is not a consequence of heating effect of electric current. Okay class, its time is over. So correct answer is yes, it is C, magnetic effect of solenoid. Okay, here again you can see, so there is an electrical bulb. How does heating effect of current help the bulb to glow? So here we can see that if any material or metal, it is heated to a high temperature, so again it produces heat and light also. So here is an activity. You can heat up a copper rod. Certain elements emit light when heated to a particular temperature. So here we will use this property to light up a bulb. The bulbs are usually filled with chemically inactive nitrogen. So all bulbs, they are filled with nitrogen gas and argon gases, which prevents the filament from getting oxidized and prolongs the life of the filament. In Latin, filum means thread, thus filament means thin metallic thread. So here you can see that if you closely look a electrical bulb, so you can see like this structure. This is a thin thread like structure, and which are in round shape. So it is thin metallic thread. So this is called filament. So here you can see this is the filament. Okay, now how does an electricity comes to our house? How does it reaches our house? So you all have seen these electrical poles inside near your house, near a road. Okay, everywhere you can see them. So what is the utility poles? So these poles carries excess current, and here these are connected with a meter, which is again is connected to our power supply. So what happen if excess current flows into our appliances? What does the excess current means? More and more current. So if it comes into electrical bulb, so again the filament gets more heated, and then it will be blow off. Okay, so excess current, it damages the electrical appliances. So here is an activity. Here you can use an electrical bulb, then there is a battery and a switch. So if you power on this circuit, so here you can see there is an excess current. Why? What is the voltage of bulb? Yes, again it is 3 volt. And what is the power supply? It is 12 volt. It means it produces more energy that than the bulb requirement. Okay, so what happens? There is excess current, so bulb will get fused. So there is excess current. Now how can we prevent this excess current to flow into the electrical bulb? So we use a device. Here you can see this is a device. This is called fuse, electrical fuse. So here we can see that if we connect electrical fuse, then when the circuit is closed, then with the excess current, this fuse again it gets broken. Okay, when it gets broken, then the electrical circuit will be open or it is broken. So it saves the electrical appliances. So this is called fuse. A fuse is a safety device that protects the circuit and the appliance. Okay, so this is called a safety device that protects the circuit and the appliance when excess current flows through it. So this is about the fuse. So fuse has different types. Here you can see these fuse are used in our home, in our home circuit. Okay, so these fuse, these protects the electrical appliances. Here we can see that a lot of fuse, they are also used in the electrical appliances, inside the electrical appliances. So inside a TV there is another fuse. So these are different types of fuse. One is 50 ampere, another 5 ampere, and there is another 15 ampere. So these are different kind of fuse. They can be blow off if the excess current is more than 50, more than 5, and more than 15 ampere. So this is the main fuse, 50 ampere. Fuse in lighting circuit, it is again 5 ampere, and fuse in power circuit, it is 15 ampere. Now why fuse differ in different devices? Do you know? Okay, so these different, because you know that different devices, they all have different capacity. They all use different amount of current to run. Okay, there is a big appliances, there are small appliances, so all they need different amount of current. So this is a fuse of 5 ampere. A 5 ampere fuse will allow a current up to 5 ampere. Okay, if any appliance need only the current which below the 5 ampere, so this fuse will be used there. So a 5 ampere fuse will allow a current up to 5 ampere to flow through it. A higher current will blow off the fuse. So this is the difference. Again, question time. What is the purpose of fuse in an electric circuit? And your time starts now. Students, and your time is getting over. So finally it is over. Yes, so correct answer is to prevent the short circuits. So the purpose of fuse in electrical circuit is prevent short circuit. Now what is the quantity of heat generated in a device? So how can we get the idea of the quantity of heat generated in a device? So here let's find out. So here we are using different kind of instruments. This is again voltmeter, this is voltmeter, and this is ammeter. So can you tell me what is the use of voltmeter? Yes, very good. It is used to measure voltage. And what is use of ammeter? Very good. It again measure the current. So here we are measuring the amount of voltage, potential difference, and amount of current. So energy consumed by the bulb depends on voltage, which is potential difference. Again it is, yes, here you can see that if you increase the amount of current, so again the bulb is glowing more. So energy consumed by the bulb depends on the amount of current flowing through it. So energy depends on voltage and also current. And energy consumed by the bulb depends on time for which the current flows through it. So energy, basically energy, it depends on three factors. First is potential difference, second is amount of current, and third time. So how much time it will take. Now work done by the bulb depends upon. So we know that the voltage and current, the work done depends on the voltage and current, and again time. So this is the formula to find the energy or heat. So energy is equals to V, I and T. V is voltage, I is current and T is time. Now what is the power? So power is the energy consumed upon time. So you all know the formula to find the power. It is work upon time. Okay, here work means energy, so energy upon time. So you can put the formula. Now P equals to VIT upon T, and then P is equals to VI. So this is the formula of power. So power equals to voltage into current. So P equals to VI. So here we can see an electrical circuit. So if we on the circuit, so it again depends on the resistance. Now amount of charge, it is equals to current into time. So Q equals to I into T. Now we can convert the formula, the work done formula in terms of charge also. Now the amount of work done in a given time to move unit charge between 2 points. So here we can convert V equals to W over Q and W equals to V into Q. So work done in unit time is VQ over T. So put the formula. Now work done is in unit time is the rate at which work is being done, and rate of doing work is power. It means power equals to W over T. So from here we can find the formula of power. Now again, by Ohm's law we know that V is equals to IR. V is equals to IR, where R is, yes, it is resistance. So we can put the formula of V equals to IR in the formula of power. So here P equals to I square into R. Again we can change also, I is equals to V over R. So put again this in this. So P is equals to V into V over R. Again V square over R. So again we can get P is equals to V square over R. So this is the formula to find the power in any electrical appliances. Now what is the unit of power? So recall the formula. What is P is equals to? Very good. V into I. Okay. And what is the unit of V? Very simple, it is volt. Now what is the unit of I? Current. It is ampere. So the unit of power is written, can be written as volt into ampere. Volt ampere. So power equals to voltage into current. It is volt, or it can be written as joule upon coulomb. Again unit of current is ampere, or it is coulomb upon second. So use both these. So unit of voltage into unit of current. Now it is again joule upon coulomb into coulomb upon second. So we can cancel out coulomb. Now it is joule upon second. So I think you have learned about this unit also. This is the unit of power, and again it can be written as watt. So here again the electrical power is same as the mechanical, the unit of electrical power is same as the unit of mechanical power, which is watt. So this is again watt. Now what is 1000 watt? Very easy. It can be written as 1 kilowatt. Okay, you know that what is the 1 kilometer? It is 1000 meter. So kilo means 1000. So here 1000 watt is equals to 1 kilowatt, and 1 kilowatt hour means 1 kilowatt into 1 hour. So if you convert all these, so this is called 1000 watt, and 1 hour into second is 60 into 60. So after multiplying you will get the 3600 into 1000, and this is 36 and 5 zeros, or you can write this one as 3.6 into 10 to the power 6 watt into second. So this is equals to 1 kilowatt. Okay, so this is the 1 kilowatt, or watt into second, it again converted into joule. So watt into second is equals to joule. So 1 kilowatt equals to 3.6 into 10 to the power 6 joule. And we also use this term 1 kilowatt hour as equals to 1 unit. So this is called 1 unit of electricity. Okay class, again question time. How is electrical power calculated in a circuit? And your time starts now. What is the formula of electrical power? So what is the formula of electrical power? Okay, your time is over. Yes, it is A, voltage into current. Now there is a question, okay, it is based upon the formula which you just learned. An electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power of bulb? So what is given to us? First this and then this. So we are given voltage. So first there is a formula, P is equals to V into I. The value of V is 220 volt and I is 0.5 ampere. It is again 110 watt. An electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of energy to operate it for 30 days at rupees 3 per kilowatt? So this is again charge of electricity, rupees 3 per kilowatt. Okay, so it is again what is given to us. This is, yes, it is power, and again time is given 8 hours per day. And how many days? It is 30 days. So again we have to find the power consumed in kilowatt hour, or energy consumed. Now total energy consumed by the refrigerator in 30 days will be, it is 400 into 8 hours and into 30 days. Okay, so after multiplication you will get 96,000 watt hour. So this is again watt hour, but we have to find in kilowatt hour. So what will we do? Yes, we will divide this by 1000, because we know that 1 kilowatt equals to 1000 watt. Now it is written as 96 into 10 to the power 3, or 96 kilowatt hour. Now cost of the energy to operate the refrigerator for 30 days, so multiply 96 with 3, it is again 288. So it means if you operate an electric refrigerator for 30 days, so you have to pay rupees 288. An electric motor takes 5 ampere from 220 line. Now you have to determine the power of motor. So again, what is given to us? Yes, it is current I, this is voltage V, and this is time. So we have to find I in ampere, V in voltage, and T in, yes, very good, in second. So first we have to convert 2 hours into second. Now power is given by expression. What is the expression of power? Very good. This is again V into I. So from here we can find the power, 5 into 220. And after multiplication you will get 1100 watt, okay, 1100 watt. And now what is the energy consumed? So how can we find energy consumed? Yes, very good, again it is P into T, and T in second. So this is P into T, where P in watt and T in second. Now we have to convert 2 hours into second, so multiply 60 into 60. So this is again 7200 second. So from here we can find the energy, 1100 into 7200. So we know that the energy or heat produced, it is again depends on V, I and R also. Now work done by a source of or energy supplied by source in time T. So this is again W over T, where W equals to P into T. So from here we can find this energy used in doing work is liberated as heat. Now for a steady current I, the amount of heat H produced in time T is H equals to VIT. So this is again the formula to find the heat. Now we use the Ohm's law, V equals to IR, so H equals to I square RT. So from this formula you can make some conclusion, okay, that H, it depends on I, it depends on R, and again it depends on T also. This is known as Joule law of heating. So what is the Joule law of heating? H is equals to I square RT. So from here H is proportional to I square, means more current and more heat is produced. H again is proportional to R, resistance. More resistance and more heat is liberated. And H is proportional to time. So again we have some metals, okay, these are conducting metals, copper, then we have nichrome. So these are different kind of metals, aluminium, and again tungsten. So these are different, they have different property in terms of resistance. Copper and aluminium are generally used for electrical transmission line. So again if you closely look a wire, so again it is made up of mostly copper and again with the aluminium, because they are the good conductor, it is the best conductor of electricity. So they are used for electrical transmission. And nichrome and tungsten are commonly used in electrical heating devices because they have more and more resistance. So if they have more resistance, so they will liberate more energy. So here you can see an electrical press. An electrical an electric iron consumes energy at rate of 840 watt. Okay, so what is given to us? First we will use P equals to VI. Now from here energy I equals to P over V, and the resistance of the electric iron is R equals to V over I. Okay, this is again 360 watt over 220 volt. Now the resistance of electric iron is from here you will use the Ohm's law, R equals to V over I. It is 220 over 1.64. Now next question is 100 joule of heat is produced each second in 4 ohm resistance. Find the potential difference. So here we are given heat H and R, and we have to find V. H is given 100 joule, R is given 4 ohm, and time is given each second. So look here, it is again each second, so time is 1 second. So use the formula H equals to I square RT, but we have to find V also, so you can use this formula also, V square over RT. So from here we can find current also. This is 100 upon 4, which is 5 ampere, and by using Ohm's law we can find voltage. Okay, again question time. So calculate the power consumed by an electric appliance that operates at 220 volt and current of 5 ampere, and your time starts now. Okay class, your time is getting over. Yes, so the answer is, it is D. Okay class, now it's feedback question. How do you feel for today's class? And your time starts now. Okay, and your time is over. So what have we learned today? So we learned about the power of an electric circuit. Okay, now we know the formula of power is V into I, and then we also learned about the liberation of heat. So H equals to VI into T, or it can be converted into I square RT, or we can write this one as V square over RT. Okay, so from here we can see that H is proportional to I square, again H is proportional to R, and H is proportional to T. Okay students, so now it's time to end the class, and we will meet in next class. Till then, goodbye and thank you.